Good morning, all of you. So we can start the lab session. So before starting the lab session, can someone respond whether you guys can hear me?
Yes, sir. We can hear you.
Okay, thank you. So lab sheet. Okay, I think I did the bitwise operators up to the left shift operator. Okay, I think I need to continue the bitwise and then onwards, isn't it? Anyone can remember the previous lab sheet? I think I did up to the left shift operator, isn't it?
Yes, sir. We did the shifts.
Yeah, okay, thank you. Now I'll continue the bitwise AND operator. Okay, you know there are several AND operators available that the relational operator, under the relational operator also there is an AND operator and the logical, sorry, so not the relational, logical, under the logical operators. So there is a AND operator that under the logical operator that you can see double AND sign. The double AND sign represent it is a logical AND operator. That means left side and the right side, if the both left and right sides are true, then the output will be true. That means both side left and right sides are non-zero values. That means output is 1. So here is the again AND operator. It is a bitwise AND operator. Okay, I'll give you an example. What does it mean by bitwise AND? First take the logical AND. Let's say int x equals 7 and int y equal 10. Then let's say int k is equal, let's say AND operator with x greater than 7 and n, y greater than 8. So then you can use the printf function. K value is %d slash n k value. So now you can run this program. You can see k output is 0. So why? The first condition x greater than 7 condition is false because x is equal to 7. Therefore, the first left side is false. That means 0. Okay, 0 mean it is not required to evaluate the right side because the left side 0 mean output is 0 because this is the AND operator. Okay, therefore k is 0. Let's say x less than 5. Okay, then x less than 5 condition true, x greater than 5 condition true, y greater than 8, that is also condition true, output is 1. Okay, that left sides give you 1 and the right side also give you 1. The both sides are 1, therefore output is 1. Okay, so it is not required to use the greater than or whatever the one. If you want, you can use the direct variable. That means x and y. Okay, so x, what is the x? Tell me what is the x value? Left side x value. What is the x value? Just tell me what is the x value.
7.
Yeah, it is 7. 7 mean whether it is true or false. 7. I told you every non-zero values are considered as true. Okay, that means 7 is a non-zero value. Therefore, 7 is true. That means left side, this side is true. Okay, and the right side, y is 10. Okay, 10 mean what is that value? True or false? Again, it is true. It is non-zero value. Therefore, both sides are true. So when you run this program, output is 1. Okay. Let's say this side is -10. Then run this program. Again 1. Why? X is 7. 7 means non-zero value. Okay. So it is true. And the Y is -10. -10 also a non-zero value. Therefore, both sides are true. Output is 1. So when you run this program, output is 1. Let's say Y is 0. Then run the program. Then output is 0. Why? X is 7. X7 means it is true. Y is 0. Okay, that is 0. I told you non-zero values are considered as true, but 0 considered as false. Okay, that Y is 0, that it is false, therefore output is 0. Okay, now I think you guys have a proper idea of the logical AND operator. This logical AND operator, double AND sign. Okay, now I'll come what do you call bitwise AND operator. Okay, let's do the bitwise AND. Let's take example here 10 and Y is 11. Okay, bitwise AND operator is only one AND sign. Therefore, I remove one AND. It has only one AND sign. X and Y. Okay. Now, run this program. Now the K is 10. How does it happen? It used the bitwise operator. Okay. Bitwise means first convert the X value to the bit. So you can say X is equal let's say X take 8 bits. So you know integer, if you take X, it is 32 bit. So here I write down that one in the 8 bits. Okay. 10. How do you write the 10? 10, you know, 1 0 1 0. That means the binary string. Suppose that integer take 8 bits. If it take 8 bits, 1 2 3 4 5 6 7 8. So this is the bit stream of the X. But the integer is 32 bit. So there are so many bits available up to the 32. Then මම මේ X කියන එක bits 8ක් කියලා උපකල්පනය කළා. දැන් මේ හදන්නේ මොකද මට bits 32ක් ඉස්සරහට දාගන්න screen එකේ ඉදමදි හින්දා. හරි. So you guys can continue with the 32 bits. Okay. So X is this one. And the Y is 11. 11 mean 1 0 1 1, I think, no? So this is 2 8 10 1. Okay, you guys can continue the 32 bits up to here. Okay, these are zeros. Okay, now it asks to use the AND operator. You know AND operator. AND operator works as the like previous. If the both sides are true, then output is true. That is the AND operator. Okay, if the one side is false, then output is false. Okay, now you have to use the AND operator with this one and this one. Okay, what is the output? 0 and 1. If you use the AND operator, 0 and 1, what should be the output? 0 and 1. What is the output?
0.
0. It should be 0 because one side is 0, the output is 0. Therefore, here bitwise, the least significant bit, this is the least significant bit, is 0. Now go to the next bit. Here 1, here 1. That means 1 and 1. Here also 1, here also 1. Then what would be the output? Both sides are 1. What should be the output?
1.
1. It should be 1. So here, this is 1. Then next one, 0 and 0. 0 and 0. You know, both sides are 0. Therefore, output is 0. It is not required to get the both sides. If the one side is 0, also output 0. But here both sides are 0, output 0. Here 1 and 1. That means 1. Okay. And 0 and 0. 0, 0 and 0, 0, 0, 0. So here also you can go the 32nd bit also 0. All are zeros. 1 0 1 0. 1 0 1 0 mean what is the value? 1 0 1 0. In the decimal, it is 10. Okay, you know this is 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Likewise, values are going. Here 8 bit is 1 and the second bit is 1. Therefore, output is 10. That is why the K value is 10. Okay. Let's take a different example. Let's say X is 15, Y is 20 or whatever the one. Okay, just convert these values. So here I convert online converters. Let's take decimal to binary. Let's take some example. Let's say what is the 15 and 20. 15 convert, it is 1111. Okay, 15, I write a comment, it is 1111. And 20, 10100. Okay. Now write down these things. Now we are going to use the AND operator now. X value is equal 1111. 1111. So you know there are leading bits 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Likewise, there are zeros available up to the 32. And the Y value is equal 20. 20 means 10100. That means 10100. And the other leading bits are zeros up to the 32 bits. Okay, now you may use the AND operator. Okay, 1 and 0. So output is 0. 1 and 0. Output is 0. 1 and 1. Output is 1. 1 and 0. Output is 0. 0 and 1. Output is 0. Here 0, 0, 0. Okay, now what is this value? 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Okay, now fourth bit is 1. Other all bits are 0. Therefore, output should be 4. Let's run this program and check whether what is the output. Yeah, K is 4. Okay, anyone has problem up to here? Bitwise operator. Bitwise AND operator. No questions. Okay, then we can move to the other one. What is that? Bitwise O operator. Okay, you know in the logical also, you have O operator, the logical side, same as here. There is another operator, but only one vertical line. If you have only one vertical line, that means it is bitwise O. Okay, that means one vertical line. Okay, if you use two vertical lines, likewise here, now that means this is logical operator. That means X is 15, that means it is true. So if it is true, no need to go to the right side, output is true. So output is 1. Okay. Let's take X is 0. So X is 0, that means here output is false, but Y 20, it is true, therefore output is 1 because this is O operator. If the both sides are true, that means if the both sides are false, that means 0, then the output should be false. Okay, this is the logical OR operator. Okay, now I'll go for with the bitwise OR operator. Take the previous example 15 and 20. Okay, only one and sign. Sorry, only one or sign. Okay, take this one again. X is equal. I think you guys can see my screen. That means writing something on the screen. That yes or no?
Yes, sir, we can see x equals written in
Yeah.
blue color.
Yeah. Thank you. Okay. X equal. So 1, 1, 1, 1 here. 1, 1, 1, 1. After that, zeros. And the y equal 20. 20 mean 1, 0, 1, 0, 0. 0, 0, 1 and 0, 1. 0, 1. Other leading bits are zeros. Okay, now you guys need to do the O operator. O operator means if the one side is true, the output is true. Okay, let's take 1 and 0. You know, one side is true here. Then output is 1. 1 and 0. One side is true. The output is 1. 1 and 1. 1 and 1 mean both sides are true. Then output is 1. True. Here 1 and 0. 1. Here 1 and 0. 1. And 0, 0, 0, 0. Both sides are 0. Then output is 0. Okay, now what is this value? 1, 2, 4, 8, 16. 16, 8, 4, 2, 1. Is it 31?
Yes, sir.
It should be 31. Okay, let's run this program. Yes, the K is 31. Okay, this is the bitwise OR operator. And the next one is bitwise XOR operator. Okay. XOR operator. What does it mean by XOR? So XOR works as a OR, that means O operator, but there is a little bit difference. That means, let's say the bit stream available like 0, 0, 1, 1, 0, 1, 0, 1. Okay. Now these are the, let's say these are the X and Y values. So if you use the AND operator, 0, 0 mean 0. AND operator. 0, 1, that means one side is false, therefore output is false. 1 and 0, one side is 0, output is 0. Both sides are 1, then output should be 1. This is the AND operator. And the O operator, if the one side is 2, output is 2. Here 0, 0, both sides are true. Therefore, sorry, both sides are false. Then output is false. Here, one side is true. Okay, then output is 1. Okay. AND operator, this is operator. And here is 1, therefore output is 1. Here both sides are 1, therefore output is 1. Okay. Now I come to the XOR operator. XOR operator returns true if X and Y are not equal. That means different values. For the different values, it gives you the true, and the equal values, it gives you false. I repeat that one again. XOR operator, equal bits is false, different bits is the true. So here 0 and 0, it is equal. 0 and 0 equal. Therefore, output is false. And 0 and 1. Okay, this is different. Bit is different because this is 0, this is 1. Bits are different. Therefore, output is 1. And 1 and 0, again different. Different bits. Therefore, output is 1. And 1 and 1, bits are equal. Therefore, output is 0. Okay, this is the XOR operator. Okay, let's take this example X and Y. X equal 1, 1, 1, 1. And Y equal 1, 0, 1, 0, 0. 1, 0, 1, 0, 0. Okay, now we are using the XOR operator. You know, if the bits are different, output is true. If the bits are equal, output is false. So here 1 and 0, different bits. Therefore, output is 1. Here 1 and 0. 1 and 0, different bits. Therefore, output is 1. Here 1 and 1, bits are equal. Therefore, output is 0. Here 1 and 0, different bits. Therefore, output is 1. Here 1 and 0, different bits. Output is 1. Okay, and 0 and 0, bits are equal. Therefore, output is 0. 0 and 0, 0. 0 and 0, 0. Up to here, this one also 0. Okay, now what is this value? You know, this is 1, 2, 4, 8, 16, 32. Likewise, is gone. So 16 bits is 1 and 8 bits is 1 and second bit is 1 and the first bit is 1. So if you add those things together, is it 17?
20.
Oh, sorry. 27, no? Is it 27?
Yes, sir.
Yeah, it's 27. Okay, thank you. Then try to run this program. But we have to put the XOR. This is the operator. XOR operator. Now run this program. Yes, it's 27. Any questions up to here with the bitwise operator? No questions. Shall we move to the MIS operators? Okay, seems to be you don't have any question. Therefore, I will move to the MIS operator. Okay, that means other than the operators, there are some unusual operators available. We call first one is size of function. Size of function mean actually it's called as an operator. Okay, so usually you may think it is not an operator, but in the C programming we call the size of also as an operator. However, this give you the size of the variable. For an example, let's say X and Y, and here I return percentage D, size of X variable. Okay, size of X variable. So if you run this program, you can see size of X variable is 4. The value inside the X variable is 15, but the size of X variable is 4. What does it mean by size? Size means how many bytes taken to store that integer variable. How many bytes taken? You know that how many bits taken for the integer variable? how many bits? In the bits wise, how many bits?
32.
Yeah, there are 32 bits. Okay. X take 32 bits. Store the values 32 bits. But this is depends on the computer architecture, that sometimes you may take X value as 16 bits. Some old computers depend on the architecture. But nowadays, the most of what do you call computers use 32 bits for the integer value. Okay, so 32 bits mean how many bytes? You know, 8 bit is equal to 1 byte. 8 bit equal to 1 byte. That means X has how many bytes?
4 bytes.
Yeah, 4 bytes. That means 32 divided by 8. That means 4 bytes. X has 4 bytes. Therefore, it's give you the output as size is 4 regardless of the value inside the integer. මේක ඇතුළේ තියෙන value එක ගැන එයා consider කරන්නේ නැහැ. එයා දෙන්නේ size එක හැමතිස්සම. So size of the what do you call that variable. Okay, therefore whatever the value you put here, let's say you put 700 and 600 and whatever the one, so output is 4. If you use 0, again output is 4. If you use minus whatever the value, since output is 4. Okay, that means size of function does not depends on the value. It always give you the size of the variable. Okay, and if you use a y also, it is 4. Let's take a different data type, char b. Okay, then you can print b here. Okay, you can say output is 1. 1 mean char takes 8 bits. Okay, you know integer take 32 bits. 32 bits mean 32 divided by 8 is 4 bytes. But char take 8 bits. 8 divided by 8 mean only 1 byte. Okay, char takes only 1 byte. That is why I always get the char for explain the bitwise operations. මම හැමතිස්සම char value එකක් ගන්න මෙන්න මේ bytes එකක් තියෙන හින්දා. නැත්නම් 32ක් යන ඉන්න එපා මේකේ. මේ char එකකින් examples පෙන්නන්නේ අඩු bytes ගන්නක් තියෙන හින්දා. Okay, now let's take a different value float b. Then you can see output is 4. 4, that means float also take 32 bits. That means 4 bytes. Okay, but I told you double take the double precisions. If you use the double, it's take 8 bytes. That means doubles the bit. Bit stream එක double වෙනවා. That's the meaning of double. Previously we used the integer, that means float we used the 4 bytes. No, double mean the size is double. Now it's take 8 bits. Okay, so likewise you can get the values. So you know that the size of function does not depend on the value. Therefore, it is not required to put the x or y or whatever the one. If you want to get the size of the function, you can provide, let's say you want to get the integer value, you can provide int. Then it show the size of integer is 4. If you need char, you can provide char. Then size is 1. If you need float, you can type float. Float size is 4. If you need double, you can type double. Size is 8. Okay, now I will give you an example. Let's take int x equal 8 and provide the x value here. The size of function with the x value, variable x. Okay, it is 4. Here I use, after that, I am printing the x value also. Printf percentage d, let's say x equal percentage d and slash n. Here x value. Previously I used size of x, that means it is 4. After that I print the x value. You know, x value is 8, but the size is 4 bytes. Okay, now here I use x plus plus. Size is 4. Whether you increase the x value or not, the size doesn't change. X value එකට මොකක් ආවත් වැඩි කරත් අඩු කරත් මොනාවත් size එක වෙනස් වෙන්නේ නැහැ. It's 4. But still x value is 8. I told you this increment operator. Okay, it increment x by 1. That should be 9. Why it doesn't happen? Let's say it is prefix operator. Then try to run this program. Still x is 8. Size is 4, it doesn't matter, but the x value doesn't change. Okay, that if you use this kind of one, print the x value here, x plus plus, just x plus plus, what happened? Put the x value to the here, that x value is 8. This is postfix operator. Put the x value as it is. After that, x increment by 1, 9. If you use plus plus x, that means first increment the x value by 1. X value by 1, that means x is 9. Okay, after that you print the x value. Again, still x is 9. That means plus plus or plus plus x or x plus plus, however it increase the x value. But if you use the size of function, size of x plus plus, it is 4, but x doesn't change. The reason is size of function, before executing this kind of one, check whether if the x value increment by 1, that means let's say it is plus plus x. Okay, increment the x value by 1. If it is increased, x value is 9. If it is increased, okay, if the value is 9, the size of function give you the same output as 4. The සිංහලෙන් කියනවා නම් මේක වැඩි කරත් මෙයාට output එක එන්නේ 4 තමයි. මොකද මේ x වගේ x අගය වෙනස් කරා කියලා මෙයාගේ return වෙන size එකේ වෙනසක් වෙන්නේ නැහැ. Okay, although you change the x value here, that means increment the x value by 1, the return value doesn't change. Therefore, the size of function does not evaluate, does not execute this one. That is the reason. Okay, දැන් සිංහලෙන් කියනවා මේ දෙක x එක එකකින් වැඩි කරා කියලා output එක වෙනස් වෙන්නේ නැති හින්දා size of function එක මේක evaluate කරන්නේ නැහැ. But remember that if the x plus plus, after you increment this one, if the value does change, then size of function is going to evaluate that one. වැරදිලා හරි මේක වැඩි කරාට පස්සේ මේක 9 වුණාට පස්සේ size of function එකේ return value එක වෙනස් වෙනවා නම් එහෙනම් මෙයා මේ operation එක කරනවා එතන. Otherwise no. Okay, so there are some situations available. The increment may change the size of the variable. Okay, in such a situation it increase. Okay, I can give you some examples of that one. If you use an array, okay, but still you didn't learn about the arrays in programming, I'll give you a brief idea of an array. Let's take, if you use int x, int x value is 8, you can store only a one value. Okay, if you use an array, how to declare an array? You can use int y. Okay, y also an integer. Within the brackets, you can provide the value, let's say 3. Okay, that means this is an array. Array means size of 3. That means this y variable can store 3 integer values. දැන් මෙන්න මේක කියන්නේ y variable එකට integer 3ක් තියාගන්න පුළුවන්. දැන් x එකට පුළුවන් 1යි 8 හෝ 10 හෝ මොනවා හරි. නමුත් දැන් y variable එකට integer values 3ක් තියාගන්න පුළුවන්. The y can hold 3 integer values. Okay, so if you use size of y, okay, here y equal it is 12. But the y you do not need to print this one y value because there is no values you have been assigned. That is why this issue. So I ignore that one. The size of y is 12. Okay, 12 mean this is integer type. Integer type has 4 bytes. Integer type has 4 bytes, but you can store 3 integer values. Therefore 4 into 3 4 byte කියන්නේ 4 capacity 3ක් save කරන්න පුළුවන්. එතකොට size එක 12ක් වෙනවා. Size is 12. Int size is 4. There are 3 integer values can be stored. Therefore size is 12. Okay, don't worry that you will be learn this kind of arrays in future lab sessions. Okay, up to here remember that arrays can store more than one value. Okay, if you want, sometimes it can be only one value, sometimes more than one value, depend on how many number of values inside this y variable. So how many slots available in this y variable? Here 3 slots available, that means 4 into 3. Okay, now we can use this kind of example. Okay, so I remove this one. Let's say x is 3. Here I use an array. Okay, so that means int array you have to represent in using the, if you use just int size of function, here if you use just int, what happen? It give you the output of size of the integer value 4. But I here use put a space array. Array mean 2 square brackets and you have to provide the value 3. Okay, size of 3. Integer is 4 into 3 it should be 12. Output is 12. Let's say this is 10. Okay, 4 into 10 it should be 40. Okay, size of 40. Okay, here I use x. Let's say x is 5. Then what should be the output? Can someone give me what should be the output? What should be the output?
20.
Yeah, it should be 20 because that integer size is 4. There are x type of integer values. X is 5. That means 5 into 4, it should be 20. Okay. After that, you can print the x value. Let's say x value is here x. Size is 20, x value is 5. Here, just print output the x value. Now I am going to use the x plus plus. Okay, if you use x plus plus, does it give you the same 20? Sorry, let's say first take the plus plus x. Okay, if you use the plus plus x, that means if the x value increment by 1, does it change the return value as 20 or different value? That means if you increment the x by 1, that means x is 6, then what would be the output?
It will be increased.
Yeah, it will be increased. That means x value, now you ask to increase, that means x value is 6. If the x value is 6, 6 into 4, that value, that 24 should be the output. Therefore, what happened? It is 24 and x has been increased. Okay, that is the example. Okay, if you increase the array size, the size of function should return the array size. Therefore, in such a situation, it increases. Although it does not increase in here, x plus plus. Size is 20. Why? It is postfix operator. Okay, it is postfix operator. So it just put the x value 5 here, 5 into 4, 20. After that, increments the x value by 1. Although you use the x plus plus, it doesn't increase the size. Size of function is going to increase because it doesn't know whether this function may give you a different value or not. Therefore, it's going to increase that one. දැන් සිංහලෙන් කියනවා නම් x දැම්මහම මේකේ value එක වෙනස් වෙන්න විදියක් නැහැ නේ 20ම නෙන්නේ මොකද x වල පහම තමයි මෙතනට එන්නේ. නමුත් මේ size of function එකට ඒක හොයාගන්න බෑ. එයා දන්නවා x හරි x දැම්මොත් එහෙම මේක ඇතුළේ වෙනසක් වෙන්න පුළුවන්. මොකද array එකේ size එක වෙනස් වෙනවා මෙන්න මේ කරන වැඩි. ඒකින්ද එයා ඒක කරනවා. ඒ කියන්නේ කරන්නේ පස්සේ කියලා තමයි කියන්නේ මේ postfix කියන පස්සේනේ මේ එක මෙතන දාලා පස්සේ x එක වැඩි කරනවා. මොකද arrays එක deal කරද්දී size එක වෙනස් වෙන්න පුළුවන්. ඒකින්ද මේක size එක වැඩි කරනවා. Therefore, you can identify when it is deal with the arrays, always size of function do that operation. Okay, don't worry that if you don't understand what does it mean by arrays or what are the things, we will teach you everything in when you come to the arrays part in the lectures and the tutorials. Okay, up to here, remember that you can get some idea that size of function just output the size of the variable. Okay, shall we move to the next part? The return the address of the variable using the AND operator. Okay, now you can see there's another AND operator in here, bitwise AND, and there's another AND operator here, double AND, logical AND operator. But there is a different logical, there is a double AND sign available. Then we can computer can identify this is a logical AND operator. But when you come to the here single AND sign, then computer can identify it is a bitwise operator, AND operator. But here also same thing. Then how does it identify whether it is a MISC AND operator or bitwise AND operator? Okay, but doesn't matter where you put this AND sign, computer can identify, the compiler can identify whether this is a bitwise AND or that MISC operator AND. Okay, however, AND sign is return the address of the variable. Okay, so don't worry, at this moment you may not understand what does it mean by address. Okay, so address mean actually so when you store this kind of thing, that means in text in the memory, there are several memory slots available. Okay, these kind of memory slots available. Okay, usually one slot is belongs to a 1 byte. Okay, so integer has 4 bytes. So if you want to store the integer, you need consecutive 4 bytes. 1, 2, 3, 4. Okay, these 4 bytes is taken for the x variable. Okay, don't worry that in this example I'll take only one slot for the x. Okay, because for the otherwise it is very hard to explain. Let's take only one slot for the x. Okay, usually it takes consecutive 4 because it need the 4 bytes. Okay, if you use char, then only one slot is enough because 1 byte char take only 1 byte. No? And remember that every slot there is a memory address. Okay, it's a lengthy address in sometimes in hexadecimal. Here I show you, here I give you some arbitrary address. Let's say AB01, address of this slot. Here AB02, second slot. AB03, AB04, AB05, AB06, AB07, AB08. Okay, just some address values. Okay, and x is 5, and after that just remove this one and int y equal x value. After that you are printing y. Okay, that you put x equal 5, therefore inside this x slot the value 5 there, and int y, and there's another variable, let's say this is the y. Okay, it is value of x has 5, the y also then 5. Okay, the memory address of x is AB01, memory address of y is AB02. Okay, so if you use that y equal x, that means the value 5 assigned to the here. If you use this AND operator, that means here you can see there is an AND operator. If you use this AND operator in front of this x, like here, okay, you cannot use the AND operator to the variable, it's a different thing. If you use AND operator likewise, the y previously you should find AND operator gives you the address of the x variable. Okay, if you use just x, the value 5 assigned to the y. If you use AND x, that means address of the variable. Address of the variable is AB01. That means instead of 5, AB01 assigned to the here. Okay, but here it will give you an error because the y is integer type variable. You cannot hold whatever the memory address here. That is why it give you an error. දැන් මෙතන error එකක් දෙනවා මෙහෙම දාන්න බෑ කියලා. මොකද යාට address save කරගන්න බෑ. මෙයාම integer values දාන්න විතරයි මෙතන තියාගත්තේ. Okay, if you want to hold an address variable, you have to put star inside of y, then there is no error. Star y mean y can hold an address of integer variable. Okay, don't worry, these things will be learned later. Since there is an operator called and sign available, that is why I told you in this way. Okay, so you can get this value, address of y. Okay, now y include the address. Okay, so if you print that y value, so address of the variable, I think you have to put it in the percentage x or something. I can't remember, it is hexadecimal value. Yeah, this is the address of the variable. So if it is used address, I think you have to use the, because this is not an integer value. If you use percentage %d, it will show it in integers. Likewise, this value. So since the address is that AB01, okay, since it is AB01, you have to use percentage. I think it should be x. Okay, but I can't remember the value actually. I think it should be x. Then it show you this is the address of the x variable. Y කියලා තිබ්බට x එකේ address එක තමයි මෙතන තියෙන්නේ. මොකද y වලට දැම්මේ x එකේ address එකනේ. So actually that BEA 9064C mean this one. So actually this is the BEA 9064C. This is the address of x you assign to here. Okay, you can get the address of the variable using this AND operator. Okay, so you can see that, sorry, I remove this one. So you can remember such operation is in the scanf function also. Scanf, let's say you are taking percentage %d, and here let's say you need to put it to a x variable. Then do you put just x here? No, you put AND x. Remember that AND sign? What does it mean by AND sign here? Here AND x mean the memory address of the what do you call memory address of x variable. Okay, because in order to scanf to assign the value to the x, scanf function need where is the memory address. So if you use AND x, you are passing this BEA 9064C. Okay, then scanf function find where is the memory address BEA 9064C and assign whatever the user input value 10 or 20 into the here. That is why we need this one. Okay, don't worry that you will be learn those things when you come to the pointers and the when you come to the pointers lesson. Just get an idea and mean give you the memory address of the variable. දැනට and කියන memory address එක ගන්නවා කියලා ඔළුවේ තියාගත්තා නම් ඇති. ඉස්සරහට කියනවා in detail යනවා අපි pointers කරනකොට. And there was a question. So can you explain again why there are 8 box there? 1, 2, 3. So that means you are asking 8 box mean in the memory address. That means 225538 are Manodya. That means here why there are.
Yes, sir.
Yeah, actually the 8 bits means just an example. There are so many memory addresses available. 8, 9, 10. That means based on your memory capacity, there are so many memory addresses available. Here I just draw only the one, just draw only 8 memory addresses. There are 9, 10, 12, likewise there are so many memory addresses available. Did you get that point? This is just an example. Okay, any other questions? The Manodya, did you understand that one or do you need more explanation?
No, sir, I got it.
Yeah, okay. Then we can move to the next part. The pointer variable. Again, I told you we'll do the pointers in the future lab session. So according to this example in the previously I mentioned, where did I put that? Here, this one. Pointer mean this is a pointer. Star y mean it is a pointer. Pointer mean it can hold the memory address. Okay, I will show it in the 2 lines. Let's say, and y is equal and x. Okay, the pointer is actually a pointer mean if you use a pointer star in front of a variable, that means variable automatically become a pointer. Pointer mean it can hold a memory address, not a value. Okay, so these kind of memory addresses can be held inside that variable. That is the meaning of star. Okay, and after that y equal and x mean memory address of x is stored in the y variable. Okay, දැන් මේ නිකන් y එකක් ගත්තොත් මේක ඇතුළට මේවා දාන්න බෑ. ඒවට ඉන්ටිජර් විතර දාන්න පුළුවන් memory addresses දාන්න බෑ. memory address දාන්න නම් කෙලිම pointer එකක් එන්න ඕන. pointer එකක් කියන්නේ memory address එකක් hold කරන්න පුළුවන් variable එකක්. ඉස්සරහින් star දැම්මම යාර memory address එකක් hold කරන්න පුළුවන්. It can hold a memory address. Okay, this is a pointer. Okay, for the today's lesson, just remember the pointer can hold a memory address. How to get the memory address is the and sign. Star y, you declare a pointer, that means declare a variable which can hold the memory address. Okay, and mean you can get the memory address of a particular variable. Okay, just at this moment you can get these things in your mind. We will do this one in detail in the future lab sessions and lectures. And there was a question. So since int has 4 bytes, that 5 should have 4 memory address, isn't it? Yes. Here I got you just example of 1 byte. So one memory address has 1 byte. Therefore, in order to store the, so wait, I'll show it in proper way. Let's say this is AB01 and so here x has 4 bytes. Therefore, consecutive 4 memory address should be taken. That means X start from here up to here. Okay. And when you declare Y, then Y can start from here. Usually that is the way of happening. Okay. Then you may get confused that what is the memory address of X? Now there are 4 memory addresses. I think this may be the question from you, Edrising, isn't it? If the X has 4 memory addresses, yes, usually it takes the first memory address to the variable. That means the Y is AND X. AND X has memory address of X as AB01, AB02, AB03, AB04. It take only the first memory address AB01. Okay. Since the Y is the pointer of X, Y know there should be consecutive memory addresses. When you put AB01, it know the consecutive 4 bytes has been taken to the memory address. It store only the one, but that compiler knows start from AB01, consecutive 4 bytes for the X variable we can use. සිංහලෙන් කියනවා AB01 දැම්මට එයා දන්නවා AB01 ඉඳන් මෙතන size එක int වල 4යිනේ. එතන ඉඳන් 1 2කට තියෙන 4ම එයාට අයිති කියලා එයා දන්නවා. හරි. මේක චා වුණා නම් එයා දන්නවා එහෙනම් මේක විතරයි තියෙන්නේ කියලා. මේක ඩබල් වුණා නම් මෙයා දන්නවා එතන ඉඳගෙන slot 8ක් වෙනකන් එයාට අයිති කියලා. Okay, because you declare the memory, that's right, you declare the pointer data type int. Int mean it can identify consecutive 4 bytes has been taken. If you use double, that compile identify consecutive 8 bytes has been taken, but store only the first memory address. I think this may got your answer. Edrising, did you get that one or do you need more? Okay. You guys no need to worry about those things because we will teach you those things in the future lab sessions. Okay, now you guys have the pointer variable. After that, the conditional expression. Okay, what does it mean by conditional operator? Okay, this is a conditional operator, question mark and this colon. Okay, before going to the conditional operator, you must know what does it mean by you must know the control structure of a program. Okay, if you write a computer program, there is a control structure. Control structure consists of 3 parts: sequence, selection, and repetition. Okay, so far you learned the sequence of a program. Sequence means when you write a program, hash include stdio.header file. After that, int main or void main. Then you have set of instructions. Let's say int x, int y, x equals 7, y equals 3, and another variable int answer is equal x plus y. Then printf answer is percentage %d and type the answer. Likewise, you can write the program. So far you have learned those kind of things. This we call the sequence of a particular program. That means when the compiler trying to execute, it take first the preprocessing part, it execute that mean expand the including part, the preprocessor part of the C program. After that, the compiler do the main function. Okay, it first execute the line number, whatever the line, let's say this is line number 1. First execute line number 1. After that, execute the line number 2, line number 3, line number 4. it is in the sequential way, one by one. That is we call the sequence. Execute one by one. First this one, after that this one, after that it here, after that here, after that here, after that end of the program. We call it a sequence. පිළිවෙලින් තමයි යන්නේ. Okay, this is we call the sequence. And there is another one called selection. Okay, based on the particular selection, based on the particular condition, the set of instruction, that means set of code, we can select to be executed. Okay, if that condition is false, another set of instruction we can set for the execution. For an example, let's say there is a x variable 7. Okay, so we can put a condition that if x equals 7, then do this kind of set of instruction, else otherwise do another set of instructions. That means whatever the printf function, another variable, these set of instructions. So this is sequential. Likewise here, sequential. This is also sequential. And this is a particular selection. Okay, don't worry, that selection part we'll do the future lab session. How do we use the selection part based on the particular condition? X equals 7, then do this one. No, otherwise x greater than 7, do this one. Otherwise this one. Likewise, we can use this kind of conditions. Okay, so the next one is repetition. Repetition means the set of instructions. Let's say this kind of instruction, repeat this one again and again for a particular amount of value. That means, let's say you need to execute this part 10 times. Okay, then we need the repetition part. Okay, otherwise you can execute this one until a particular condition match. Until x greater than 7, do this one again and again. Okay, likewise, this is the repetition. Okay, don't worry that this part we cover later. Okay, today you need to get the basic idea of a selection. Selection means based on the condition, you can select a particular path to be executed. Okay. Okay, and so we have several syntax to do this one. You will be learned later. Okay, but in the operators part also, we can do this conditional part. That means selection part for some extent. Okay, that means question marks give you the condition to be evaluated. If the condition is true, you can write whatever the things in between. That means if it is true, whatever the set of instruction to be executed, you can provide in between question mark and this colon. Okay, if the condition false, what is the instruction to be executed, you can provide after this colon. Okay, I'll give you an example. Okay, let's take an example, real world example. Let's say good morning and good afternoon. Okay, we usually say good morning before 12 noon. Okay, let's take example. If time less than 12 noon, we just say good morning. Say good morning. Okay, otherwise, else mean otherwise. Otherwise, you can say good afternoon. Okay, let's say we have only good afternoon and so good morning and the good afternoon. Okay, that usually after 6 p.m. we say good evening or something. So don't suppose that there is no just good evening thing, just we have the good morning and good afternoon. Okay, before 12 noon we say good morning, and after the 12 noon, that means 12 noon and onwards, 12 noon and after the 12 noon we say good afternoon. Okay, let's take this kind of one. There is a variable. Let's take a variable. to hold the value of the time. Let's say int time. Okay, let's say user enter the 12 or 13 or whatever the let's say the user enter values in if the time is 1 p.m. let's say user enter 30. හරි දැන් හිතන්නකෝ දැන් වෙලාව හවස 1යි නම් 1 කියලා එන්ටර් කරන්නේ නැහැ 13 කියලා එන්ටර් කරනවලු උපකල්පනය කරනවා. We just assume it is user entered the value as 13 in the 24-hour format. Okay, and in time and ask user to enter the time printed. Enter hour time of hour of the time in 24-hour format or something. Okay, ask user to enter the time 1 2 3 4 up to the let's say start from 0 mean midnight 12 and up to 23. Okay, then you can use a scanf function. Let's say this is integer, since it is integer value percentage d, and you signed as and time the variable. Okay, now we have the time in the time variable. We assume that user enter the time in between 0 to 24. අපි හිතනවා user enter කරන්නේ time එක බිඳුවේ ඉඳලා 23 දක්වා. වෙලාවල් තියෙන බිඳුවේ ඉඳලා 23 වෙනකන් තියෙන්නේ. හරි. මෙහෙම enter කරන වෙලාව උපකල්පනය කරලා තමයි හදන්නේ. හරි. We assume that user enter the time in between 0 to 24. Okay, now we can put the condition. If user enter time less than 12, we can say good morning, otherwise good afternoon. So how do we can use that one? We have to use time less than 12. So this is we have to use time less than 12. Then we have to use that question mark. Okay, question mark. That means left side of the question mark should be the condition. So this is the question mark. So this is the left side of the question mark should be the condition. Okay, if this condition is true, the output, that set of code to be executed should be written in the right side. Okay, then question mark එකට වම් පැත්තේ තමයි condition එක දාන්නේ. ඒක සත්‍ය වුණොත් true වුණොත් මොනවාද කරන්න ඕන තමයි දකුණු පැත්තේ දාන්නේ. The right side you have to provide whatever the instruction to be executed. Okay, what is the execution? We have only one instruction, say good morning. Okay, you can say printf good morning. Let's say gm or good morning. Okay, then we have to provide this colon, provide the colon. Okay, that means right side of the question mark or left side of the colon should be the instruction to be executed if the condition is true. Okay, the right side of the colon should be the instruction, right? That means right side of the colon should be the instruction of, that means whatever the instruction to be executed if this condition is false. මේ condition එක true වෙනවා නම් කරන්න ඕන ටික මෙතන ලියන්න ඕන. false වෙනවා නම් ඒක සත්‍ය නැත්නම් false වෙනවා නම් කරන්න ඕන ටික මෙතන ලියන්න. Okay, if this condition is true, we have write the instruction to be executed here. If this condition is false, we have to provide the lines to be executed. So no, you know, else mean otherwise, then you have to say good afternoon. Then printf good afternoon. I erase this one, otherwise you can't see the screen. Okay, then you have to provide the semicolon, that is end of the line. Okay, let's run this program. Okay, it asks enter hour in the time in 24-hour format. Let's say 10. Let's say it's a good morning. Okay, I again run this program. Let's say 14. Then good afternoon. Let's say 12. Again good afternoon. Good afternoon. 12 means the condition is false. Time is less than 12. Less than 12 is the good morning. The equal 12 mean now you enter the 12. Equal 12 mean it is otherwise. Go to the good afternoon. Okay, this is we call the conditional operator. Okay, we can use the selection part, selection of the control structure of the program using these conditional operators. Okay, but usually there are several syntax available how to write the proper way, how to properly write the conditional operators. You will be learned later. Here you can get a simple idea. We can write the conditional, that means selection part using this conditional operator also. Any questions up to here? Yes or no? It seems to be you don't have any question, therefore I'll move to the next part. The operator precedence. That means if you have several operators, what is the actually execution order? Okay, in arithmetic. So this is usually happen, most of things happen in the arithmetic operators. As in the arithmetic, the operators used in the program have their own priority order. Priority order means precedence. What is the order to be executed? The precedence when carried out this operation is as follows. Okay. For an example, let's say in the mathematical also, if you write a program, that means let's say x equal 10 multiplied by 2 plus 1. Okay. How do you execute this one in mathematics? 10 into 2 is 20 plus 1, answer is 21. Or let's say x equal again 10 into 2 plus 1. X equal 2 plus 1 is 3. 3 into 10. X is 30. Okay, which one is the correct? This one or this one? That means left side or right side?
Left side, sir.
Yeah, this one is the correct one because you know in the mathematical multiplication has the highest priority than the addition and the subtraction. Okay, this is therefore this is the correct way of execution. Okay, same thing here when you come to the what do you call operators, there is a operator precedence. So this is the operator precedence available from 1 to 9. So here also you can see this is the multiplication division. They have higher priority than the add and the minus. May add minus වලට වඩා වැඩි priority එකක් මෙතනක් තියෙනවා. Like in the mathematics, okay? The highest priority is given for the increment and decrement operator. This is not the plus and minus, okay? This is plus plus and minus minus. That means x plus 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 x, increment and decrement, they have the highest priority. Okay. After that, the logical not operator. I think you know that there are logical operators we learn, and then OO not operator. Okay. After that, the not operator. After that, we have the multiplication, division, and multiplication, division, and remainder operator. After that, plus minus. After that, relational operators, less than, no, equal, likewise. After that, right, greater than, no, equal. After that, priority has to the double equal sign. That means whether it is equal to a particular value and not equal. After that, logical AND operator. After that, logical OR operator. Okay, likewise, those are the operator precedence available. If the same thing available in that, suppose that now these ones has the suppose that in a particular expression we have the what do you call multiplication and division, both of available in a particular expression. In such a situation, it evaluates from left to right. Let's say we have x value is equal 10 multiplied by 3 divided by 2. Okay, then which one has a priority, divide or multiplication? Because they have
Multiplication.
they have in the same level. If it is same level, it evaluates from left to right. That means 10 multiplied by is 30, 30 divided by 2 is 15. Okay, but if you write this one in here, 3 divided by 2, 3 divided by 2 multiplied by 10, then what be the operation? First, division. 3 divided by 2 is 1.5, but 0.5 will be ignored because this is integer division. Okay, 0.5 will be ignored. Therefore, output is 1. Okay, and multiplied by 10. So, output is 10. Okay. If you evaluate in this way, output is 15. But if you evaluate in this way, output is 10. Okay, I think we can get this example. Let's say int x is equal 10 multiplied by 3 divided by 2. And int y equal 3 divided by 2 multiplied by 10. Printf x equal %d and y equal %d. Now I am going to print both x and y. Okay, after that I put the slash n. Now I have to provide the x and y, comma, first %d for the x, therefore I provide x, comma, second one y, I provide the y. Sorry, y should be inside. Okay, now you can get the value. X is 15 because 10 into 3 is 30. 30 divided by 2 is 15. But if you use 3 divided by 2 multiplied by 10, y is 10. Because 3 divided by 2 is 1.5, but point values will be ignored. Only 1 is the output. 1 into 10 is 10. If you need the floating point values, then you need to use the 0.0, 3.0. Now this is floating point. Now you can get the same output as 50. 3.0 කිව්වහම මොකද වෙන්නේ? 3.0 කියන්නේ මේක integer එකක් නෙමෙයි. මේක floating point number එකක්. එහෙනම් floating point division එකක් කියන්නේ. float එකක් divide බෙදනවා integer වලින්. කොහේ හරි float එකක් හරි double එකක් හරි තිබ්බා කියන්නේ උත්තරේ අනිවාර්යෙන් floating points එනවා. Therefore output is 50. floating point නැතුව නිකන් integer විතරක් දැම්මොත් integer division යන්නේ දශම ස්ථාන හැලෙනවා. So you have to get this one carefully in your mind. Okay. And okay, this is the end of the lab session. Anyone has questions? Did you try out this one? Last one? I think that means you can write the output of the program by copy and paste this one to the IDE, but you have to get the idea. How does it happen? Okay.
So I have a question, a couple of questions, sir. One is about that activity where we are supposed to calculate the size of the data type.
Activity means exercises.
Exercise, sir.
Which
Number 7, I think.
Second, what will
Number
be
7.
Number 7.
Yes, sir. Are we supposed to get the data type as an input or
Yeah, wait, write a C program to calculate the size of the data type of variable using the size of. That means it is that size of the data type or variable. That mean
The question is like, should we get the considerable type from the user as input, or we just put integer
No.
and get the
yeah,
type
you
of
can
input?
just put the size of int. That mean using the variable. That mean size of int. Okay. Int x is equal this one, or otherwise the second value is rather than putting int, you can provide int k. After that, provide the k. That is the two-way.
So we have to just use only int, right? We don't have to consider a bunch of stuff.
Calculate the size of data type using the variable. So you can use either int or float or char.
Okay, anyone, right? Anyone.
Because the question doesn't mention anything about whatever.
Yeah.
You can use whatever the thing. Okay.
Okay, the other question is, I tried to using that conditional thing, the ternary operator,
Uh-huh.
and it won't execute without the else part. Is there a quick fix for that?
Else part.
Yes, like the ternary operator after the colon, if
Mhm.
it's a blank, let's say if it's Monday,
Mhm.
say welcome week, else I don't want anything to happen.
Okay, let's say k is equal 1. You need to use the conditional operator k equal 1. Then you have to provide printf Monday or something. That means else you do not need to provide anything, no? In the else
Yes.
part, I think usually we can write the else part without so we can write the if, only the if condition without else when you come to the proper if else condition, but in the
In here it won't work.
yeah, I think here you have to put something. That means let's say 1 or something. Then it is Monday. So won't print anything. That means you have to provide something, whether whatever the value or anything. You have to, that means because the conditional operator asks there should be something. That means the else part. Therefore, if you don't have any else part, you can provide the likewise a letter, C or something, or otherwise a number, or otherwise printf nothing. Okay, likewise you have to provide something because it does not support without the else part. Did you get that point?
Yes, sir.
Yeah. Any other question?
That's it for today, sir.
Okay. Then okay, when it is asked for the right of the output of the program, you have to provide the reason for the output. Okay, write the proper reason. Otherwise, you can copy and paste and execute everything. So you can get these are the output. No, you have to provide how did you get this output. Okay, for an example, take this one. Int a is 0xFFFF. So f value is in hexadecimal format. Okay, you know the hexadecimal value, no? The decimal values, if you use the decimal values, okay, so first take the binary values. If it is a binary value, only two values are available, 0 and 1. Okay, if it is a octal value, let's say this is binary. I'll use this one. Binary values, we have only 0 and 1, two values. If it is octal, we have values 0, 1, 2, 3. Let's write it. If it is binary, 0 and 1. Octal, we have 0, 1, 2, 3, 4, 5, 6, up to 7. අටේ පාදින් ලියනවා නම් මෙච්චරයි numbers එන්නේ. Binary ලියනවා නම් දෙකයි. Octal, decimal, we usually familiar with decimal values. No, decimal 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 9. Okay, and the hexadecimal, Hexadecimal has 16 values. Okay, then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. 0 to 15, there are 16 values. Here 0 to 9, we can use the whatever the decimal values. 0 to 9, we can use whatever the decimal values. But here 10, 11, 12, we cannot use this one. We have to use a different one. That means alpha, beta, or whatever the values. Okay, here, since this is 10, we use A, 11, B, 12, C, D, 13, D, 14, E, 15, F, A, B, C, D, E, F, up to F. Okay, that's 0. Then hexadecimal values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 mean A, B, C, D, E, F. Those are the hexadecimal values. And again, there was a question. So could you provide the reason for all the problems? Disanayak. Could you please provide the reason for all the problems? What does it mean by what are the problems? I don't understand what are the problems for the reason. You are asking the provide the reason for all the problems. What are the problems? Could you please explain that part? I don't understand. Okay. Now you can provide the values to the variable using decimal or hexadecimal or binary or whatever the way. Let's take int k equal 34. Okay, if you directly put 34, that is computer identify you 34 written in what do you call decimal. Okay, so if you are providing that one in octal, you have to provide 034. Okay, 034 means it is written in octal. So if you printf percentage d, that means k variable percentage d slash n k. Okay, actually percentage d means decimal. In the decimal value is 28. In the octal 34. අටේ පාදයෙන් 34 කියන්නේ decimal වලින් 28. Okay, so if you want to provide that 34 in octal, you have to provide 0 in front of that one. Okay, let's say 38. So it gives you an error because in the octal we don't have 8. Octal value should be up to 7. Okay, so therefore we can provide 37 or something. Okay, the decimal value is 31. Likewise, you can provide the values in octal. It's 0. If it is octal and the decimal, we can directly provide. Hexadecimal, we have to use 0x. 0x. Remember that this is 0. Okay, not O. පටලවා ගන්න එපා. මෙතන O දාන්න යන්න එපා. මෙතනට එන්නේ බිංදුව. Okay, 0x 37. Okay, 37 mean in 37 in hexadecimal. Decimal value is 55. Okay, in the hexadecimal we have ABCD values also. Let's say 37A. Okay, the decimal value is 890. Okay, I think you know how to convert decimal to the hexadecimal, binary, those things. Okay, and suppose that now we need to provide it in binary 1, 0 and 1. Then we have to provide OB. It is binary. If it is binary, you know the 3 and 7 values are not there in the binary. No? If you use OB, we have to use in the binary format. That means 1, 0, 1, 1, 0, likewise. It is in binary. Sorry, let's say 1, 0, 1, 0. 1, 0, 1, 0. 1, 0, 1, 0 means you know it is the 10. 10 will be 1, 0, 1, 0 kilo. So you can provide run this program, the k value is 10. Okay, 1011. 1011 means 11. Okay, that means k value is 11. Okay, likewise, you can provide those things. Okay, that is way of writing this one. Okay, now int a. Int has 32 bit. OX mean value FFFF in hexadecimal. Binary value is this one. If you convert it to the binary, this is the binary value. Okay, how many ones available? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, the last 16 bit is 1, and the rest, the values, we have to guess what is the value. Okay, that means the other things are zeros. Okay, that means 0, 16 is available, 0, 1, because this is 32 bit. And the char 0xAA. Okay, that means value AA in hexadecimal. Binary value is 10, 10, 10, 10. Okay, then you can provide unsigned char. Unsigned char means there is no any minus or plus value, just you can provide the value AA. This is the AA means same value, OXAA. Again 10, 10. So when you run this program, let's forget about first A. Let's try to print the B and C values first. B is 0xAA. Okay, B value in hexadecimal, this one in the decimal, it is minus 86. Why it is minus 86? Because 0AA means 10, 10, 10, 10. The value char B. Okay, char B 0x1AA, 0xAA, hexadecimal AA, binary value is 10, 10, 10. Okay, there are okay, before executing 1010, if it is char, how many bits taken to store the char value? How many bits we need to store the char value? Char ka save
8 bits, right?
we need 8 bits. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, the values to be stored is 10, 10, 10, 10. 10, 10, 10. Okay, that means entire 8 bits has been taken for store this value. Okay, now we are asking what is this value? Okay, what is this value? Take the most significant bit. This is 1. 1 means whether this is a minus value or plus value.
Negative value.
Yeah, it is a negative value. Okay, how do you get the value? We have identified it is a negative, but how to get the value? What is the negative value? What is the way of getting the value?
Flipping all the bits and adding 1.
Yeah, we have to flip all the bits. That means invert all the bits. After that, add 1. That means you need to get the 2's complement. Okay, in order to get the value. First, take the 1's complement. 1's complement means invert the bits. Okay, bits take 1, that means 0. 0, 1. 1, 0. 0, 1. 1, 0, 0, 1. 1, 0, 0, 1. Okay, now this is the 1's complement notation. But we need to go for the 2's complement notation. 2's complement need add 1. Okay, we need to add 1. Okay, add 1 mean the front values are 0. Okay, 1 and 1 is 1, 0. 1 and 1 mean 2. එකයි එකතු කරාම දෙකයිනේ. දෙක කියන්නේ decimal binary වලින් එකයි බිංදුව. 1 and 1 is 2. That means 1, 0. We just put 0 to here. And 1 should be carry forward to the next location. 1 should come to the here. Then 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 0 is 0. Okay. Now this is the value. You know, however, it is negative. Now you know this is the value. How to get the value? Convert it to the decimal. Here 1, 2, 4, 8, 16, 32, 64, 128. 128 bit is 0, therefore we can ignore. 64 bit is 1, therefore take the 64. 32 bit is 0, therefore we can ignore. 16 bit is 1, take the 16. 8 bit is 0. 4th bit 4 is 1, therefore we can take the 4. 2 also 1, therefore we can get the 2. 1 is 0, therefore we can ignore. So you can add those two together. 6 and 4, 10. 10 and 14. 14 and 16. And the 7, 8. The value is 86. However, since the most significant bit is 1, this is negative value. So therefore, this is negative 86. Minus 86. Okay, that is why the output is mentioned as minus 86. Okay, sometimes you may think that in the integer also the first bit is 1. Here, then that value also should be minus. No. Why? Integer can store up to 32 bits. Integer වල 32ක් දක්වාම දාගන්න පුළුවන්. දැන් මෙතන දාලා තියෙන කීයක් විතරද? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Only 16. So you can store another 16. So they will automatically become 0. Okay, there are 1, 2, 3, 4, likewise 16 bits available. And there's another 16 available because there's 32 bits. They are automatically 0. Okay, therefore most significant bit here 0. Since it is 0, this is a positive value. You can directly convert. That means if you convert that one, let's say binary to decimal. What is this value? Just copy this value. $65,535. So that is why the value is positive value. I think you guys can understand. And the next one is unsigned char. Okay, the same thing. So previously that we used the signed char 0AA. Again, there is another variable C. Again, it is same value, but the data type is different. The data type is same, but the sign is different. This is unsigned. Okay, the same value 1010 1010. Okay, now this is unsigned. Okay, then do we need to consider the most significant bit for the plus and minus? Do we need to consider?
No, sir, we just consider the whole thing as a positive.
We have to take the whole thing as a value. It can be a positive or negative or whatever. We don't know whether value, they are just a value. Usually we say it is a positive value. Negative values are not allowed. If you want, you can say it is a all are negative or all are positive, whatever the thing. However, just a value. Okay. Then what you can do, you can directly convert. Okay, how did it convert? Here 128 bit is 1. 64 bit is 0. 32 bit is 1. And 8 bit is 1. And second bit is 1. These are the values now. So you can add 8 plus 2 is 10. 8 plus 2, 10. 10 plus 20. You can provide 0, 2, 4, 5, 6, 7. 170. Am I correct? Okay, 170. There is no any sign whether positive or negative, just a value 170. So I think the output is, yes, the C value is 170. I think you guys can understand, and there's a question. So could you please explain why the B and C got different hexa values? Yes. B is a signed value. Okay. If it is a signed value, we need to consider the first value because first bit is taken for the sign. The rest of the bits taken for the value. So since the first bit is 1, it is a negative value. Okay. If you think this is a signed char. Okay. Signed value. Okay. Char B mean by default it is a signed value. Therefore, first bit is 1. It is a negative value. How do you get the negative value? We need to get the 2's complement. How to get the 2's complement? It is very easy. Just invert the bits. Just flip the bits. After that, add 1. Bits ටික අනිත් පැත්ත හරවන්න එකත් එකතු කරන්න. එතකොට value එක එනවා. මෙතන පළවෙනි එක එක නම් ආවේ. ඒ කියන්නේ ඍණ එකක් කියලා ඍණ value එකක් කියලා දන්නවනේ. value එක ගන්න bits ටික ඔක්කොම අනිත් පැත්ත හැරවුව එකත් එකතු කරන්න. Just invert the bits. After that, add 1. This is the value. Value is 86. Okay. However, we know it is minus. That is why B take 86. Okay. But if you take C, it is a signed char. It is a signed value. That means most significant bit has not been taken for the plus or minus. අපි දැන් මේ most significant bit එකක් මම ගණන් කරන්නේ නැහැ. මොකද plus minus value කතාව මේකේ මුකුත් නැහැනේ. මේකේ sign එකක් නැහැ. plus ද minus ද කියලා sign එකක් නැහැ. ඒකයි මේ unsigned කියලා කියන්නේ. Sorry, unsigned. Okay. The whole thing, whole 8 bit is a value. So what you can do? Just directly convert this one to the decimal. So here this is 128, this is 64, this is 32, 16, 8, 4, 2, 1. Just convert, it is 170. Okay, did you get that point? I am asking about the hexadecimal values. Could you please explain the B and C got the different hexadecimal value? Actually, it is not the different hexadecimal. It is same hexadecimal. Here,
Sir,
yes.
sir, in the answer, B in hexa and C in hexa, why they got different hexa values?
Because the thing is, so now this is a positive values now that this is a 170. Okay, 170 in hexadecimal. So take this one hexadecimal to decimal. Sorry, decimal to hexadecimal. Okay, 170. Convert. It is double A because actually the so here take B value is 0x AA. C value is 0x AA. This is signed int, this is unsigned int. Okay. Actually, the value here is minus 86. Actual value of this one is minus 170. Okay. So when you output it using in what do you call decimal or hexadecimal, whatever the one, therefore output is this one. Do you understand that thing? Because this is 170. That is why although you use that, what is we have put? AA and AA. So this is different value because this is minus value. 170 directly you can provide this one as AA, but the minus value you have to provide in this way. Minus 86. I think we can provide minus 86. Okay, minus 86, it is FFAA. So this is FFAA. By usually, since although this is a char value, you are providing the values using what do you call 32-bit format. Okay, in 8-bit format, this is FFAA. If you convert it to the 32-bit, so if you provide this one in 32-bit, in front of you have to provide FFFF likewise. Then may 8-bit වලින් පෙන්නනවා නම් මේක output එකේ එන්න ඕන මේ අන්තිමට එක විතරයි. හරි? නමුත් මේ 32-bit වලින් පෙන්නන හින්දා ඉස්සරහට F4 කුත් එනවා. It's in 32-bit format. 64 වලින් පෙන්නනවා තවත් F එක ඉස්සරහට එනවා. Okay, do you understand? Because although they are although you put the same value to A and B, the problem is when you are providing that value, unfortunately, the most significant bit become ones in char B. That is why the value is different. දැන් මේ value එක දාද්දි මොකද වුනේ? මේ B value එකේ අපි නොහිතූ වෙලා මේ නොහිතූ ලෙස පළවෙනි bit එක 1 වුණා. කියන්නේ most significant bit. 1 වුණ ගමන් මේක minus value එකක් වුණා. එතකොට output කරද්දිත් මේ minus එක තමයි output කරන්නේ. Did you understand that, Fernando KJN?
Yes, sir. Thank you, sir.
Okay. Okay, then what you have to do, another example, where did you store? Okay. This is the code we have been taken. And when you run this program, 65 minus 86. Okay, next one is A and B. A and B in hexadecimal and A and B in decimal. Okay, AND operation. Okay, how do we get the AND operation A and B? A is FFFF, B is 0xAA. We have to provide the AND operation. First, FFFF mean this is the value. Take the A. A equal FFFF, that means 16 ones available. But you know, since A is integer value, it has 32 bits. Therefore, I write the 32 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, 32 bits. Okay. The value you stored is 16 ones. So you can calculate that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 ones available. Okay. That if you don't know, you can convert FFFF to binary. FFFF. So you can see there are 16 ones available. Okay. Now I provide that one here. 16 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then what would be the rest of the bits? Rest of the bits? What should,
Zero.
yeah, they should be 0. 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 zeros available, 16 ones available, altogether 32 bits. Okay, now we need to do the AND operation with the B. Okay, AND operation with the B. What is the B value? It is 1 0 1 0 1 0 1 0. That means here 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0. Okay, but can you do the AND operation with the 8 bits and the 32 bits? Can we do the AND operation with the 8 bits and the 32 bits? We can do
Then
the
others might be considered as 0.
no. There is a way to check whether what is the leading bits, whether it is 0 or 1. Okay. So this is the most significant bit in whatever the 8-bit value. If the most significant bit is 1, the rest of the bits should be filled with 1s. If the most significant bit in, because this is the most significant bit, because most significant bit decide this value is minus or plus. Okay, here this is not the most significant bit. Make a most significant bit එක. හරි ඒක හින්දා මේක කෙලින්ම plus value එකක් කියලා අපිට ගන්න පුළුවන්. ඉස්සරහට බිඳු දාලා. නමුත් මෙතන ප්‍රශ්නයක් ආවා. So there is an issue because most significant bit 8 bits is the char value. Most significant bit is 1. Therefore this is a minus value. So when you are considering with the 32 bit also, in the 32 bit also it should be considered as 1. කියන්නේ මෙන්න මෙතන 1 වෙන්නත් ඕන. කියන්නේ බිඳු ඔක්කොම එකේව තමයි ඉන්නේ මෙතනින් එහාට. Okay, if you don't understand how does all values become ones, I can explain that one. You know this value. We identify it is minus 86 because we 1 0 1 0 1 0 1 0. We identify that one as a minus 86. No. However, we identify this one as minus 86. Did you get that point? Yes or no? Did you get this point minus 86? Make a so then what you can do, the minus 86 should be represented in 32-bit format. මේ ඍණ 86 8 bits එකේ තියාගෙන අපි මේක කරන්න බෑ, මේක 32 bits වලින් පෙන්නන්න ඕන. Okay, how do we convert minus 86 in 32-bit format? Okay, you know how to convert that bit. First you have to write plus 86 in 32-bit format. After that, convert it to the 2's complement. Then it will automatically become minus 86. දැන් සිංහලෙන් කියනවා නම් ධන 86 32 bits වලින් ලියා ගන්න. ඒක 2's complement කරන්න. එතකොට ඒක minus 86 වෙනවා. Okay? How do we get the plus 86? Take the plus 86 decimal to binary. 86. Convert. This is 1 0 1 0 1 1 0. Okay. 1 0 1 0 1 1 0. Okay. This is the plus 86. We need the minus 86. First, you need to get the plus 86. If it is plus 86, most significant, that means rest of the bits we can know they are zeros. Plus 86 na ඉස්සරහදී ඔක්කොම බින්දු. Up to here, 32nd bit, it is 0. This is plus 86. Okay. We need to convert it to the minus 86. How to convert it to the minus 86? Just invert the bits and add 1. Bits ටික අනිත් පැත්ත හරවන එකක් එකතු කරනවා. එතකොට මේක minus 86 වෙනවා. මේ plus 86 මේක minus 86 කරන්න bits ටික අනිත් පැත්ත හැරවුම එකක් එකතු කරනවා. So just invert the bits. 1 0 0 1 0 1 0 1 0 1 1 1. That means all these zeros become 1. And more significant bit also 1. Okay, just invert the bits. And after that, plus 1. Add 1 to here. Okay, we need to add 1. 1 and 1 is 1 0. Put 0 to here. And this 1 should be carried forward to this location. Okay, 1 and 0 is 1. 1 and 0 is 1. And 0 and here, you know, since you are adding 1, the other values are zeros. එකක් එකතු කරන හින්දා මේ ඔක්කොම බිංදු තමයි තියෙන්නේ. Okay, 1 and 1, 1 0, put 0 to here, 1 should carry forward to this location, and 1 and 0 is 1, and 0 0 is 0. මේ උඩ එක අමතක කරන්න දැන්. So we have to forget about this one. We are adding this one and this one. This value we need to add 1. 1 and 1, 1 0, 0 put to here, 1 carry forward to this location. 1 0 0 is 1, 0 0 is 0, 1 0 is 1, 0 0 is 0, 1 0 is 1, 0 0 is 0. Here 1 1 1 1 1. Likewise, you can add 1 and 1, and here also you know 0, 1 0, it is 1. මේ ඔක්කොම එකේම තමයි එන්නේ. මොකද මෙතනත් එකේවනේ තිබ්බ දිගට. So 1 0. Okay, now this is the minus 86. Okay, check this value and this value. Here you can see 1 0 1 0 1 0 1 0 in the 8-bit. But 32-bit, you can identify the same pattern. First 8-bit 1 2 3 4 5 6 7 8. First 8-bit, you can identify same pattern. 1 0 1 0 1 0 1 0. Here 1 0 1 0 1 0 1 0. Same pattern. But rest of the bit, what? What is the rest of the bit? Is it 0? Minus 86 ඉස්සරහා bits එක බිංදුවද වැටෙන්නේ? 0 or 1?
1, right? Because the most significant bit is 1.
Most significant is 1 because it is 1. Therefore, so we can simply get the short way of representing. If the most significant bit is 1, when you convert into the 32 or 64 or 128 or whatever the one, the rest of the bit should be filled with 1. 32 නම් මේ ඉතුරු 32ට මේකේ දානවා. 64 නම් ඉතුරු ඔක්කොටම 64 දාගෙන යනවා. මේ වෙනවා වෙන හැටි. ඔක්කොම ඒවට එන්නේ එකේම. So we have to provide 1. So we have to represent it in 32-bit format. So I'm not going to write everything. So here you have to fill it 1, 1, 1, 1, 1, 1, 1, 1, 1. Here 1, 1, 1, 1. Yeah, fill කරගෙන යන 1, 1 වලින් හරි. And here also 1. You have to fill all the things with 1. Okay. Now I am going to erase this part. Sorry. I'm going to erase this part as this value and this value. Okay, now we can do the AND operation. Okay, because we are going to the අමතක කරන්න මම මේ AND operation එක ගන්න තමයි ගියේ නැත්නම් මේක මතක නැහැ මොකක්ද කියලා. So we are going to use the AND operation. Okay, now how do we get the AND operation? Let's put a line here. Okay, 1 and 0. AND operation. What is the value? 1 and 0?
0.
Yeah, it is 0. 1 and 1, it is 1. 1 and 0, it is 0. 1 and 1, it is 1. 1 and 0, it is 0. Tell me whether I am doing a mistake or not. 1 and 1 is 1. 1 and 0 is 0. 1 and 1 is 1. Here 1, 1, here 1, 1, 1, 1, 1. May they got 1. Here 1 and 1, 1 and 1, and here 1 0. 1 0, that means 0. 1 0 0. 1 0 0. මෙතන ඔක්කොම 1 උනත් ඉස්සර ඔක්කොම බිංදු හින්දා මොකද වෙන්නේ? මේ ඔක්කොම 0 වෙනවා. Although all these are 1, the rest of the other bits are 0, all will become 0. And here also 0. Okay. And this is the AND operation value. So this is the A and B. A and B. Okay. Now consider the most significant bit. What is this most significant bit? Whether it is 1 or 0.
0.
0. That means this value is a positive or negative value.
Positive.
Yeah, it is positive. Then what you can do? You can directly convert this one to the, what do you call,
Decimal.
decimal. How many ones available? 1, 2, 3, 4, 5, 6, 7, 8, 10, 9. Convert binary to decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, 0, 1, 0, 1, 0, 1, 0. 0, 1, 0, 1, 0, 1, 0. So this is the value. No? We just convert. It is 65,450. It is a positive value, 65,450. Yeah, 65,450. That is the how A and B arrive. Okay, did you get that point? Yes or no? Any questions? How did you get this one? This value is 65,450. This is how you have to do the AND operation. Okay, then when you are writing the answers, you have to get the meaning. That don't put that whatever the things this is. You can write. Okay, this is this one. Okay, you had just explained how did you get this answer. Okay, and A and C. When you use the A and C, it is 170. Okay, A and C. Okay, C value, you know, the C value is 170. Okay, that means there is no any sign available. 170. That means B and C also the same thing. No, that means wait, we got 10, 10, 10, 10, 10. This is the value. No? 10, 10. So here I put a line to identify that one in a different color. Okay, here we separate that one. No? So 10, 10, 10, 10. Okay. Then the rest of the bit you filled with 1 because the most significant bit is 1. Okay. But C, although the most significant bit is 1, is it a negative value for the value C? Value C will make a negative.
No, sir.
No, it is positive value. Then the rest of the bit should be filled with what?
Zeros.
Yeah, this should be filled with zeros. If it is C, these values should be filled with zeros. These are not 1, they should be 0. Okay, and this one also 0. Now you can do the AND operation. Yeah, I erase this one. Here, now rest of the bit filled by 0. Now you can do the AND operation. 1 and 1 is 1. Sorry, 1 and 0, it is 0. 1 and 1, it is 1. 1 and 0, it is 0. 1 and 1, it is 1. 1 and 0, it is 0. 1 and 1, it is 1. 1 and 0, it is 0. 1 and 1, it is 1. Here 0. All the bits are 0. Therefore, we do not need to consider the upper part. All are zeros. Now, පල්ලෙහා bits ඔක්කොම 0 නේ. උඩ බලන්න දෙයක්වත් නැහැ. කොහොමද 0 තමයි එන්නේ. all 0, and up to here also 0. Okay, now actually this is not the B, this is C. So this is A and C. A and C is this one. Okay, what is this value? 1 0 1 0 1 0 1 0. Okay, most significant bit is 0. Most significant bit is 0 means whether it is positive or negative value. Okay, whether it is positive or negative.
Positive, right?
Yeah, it is positive value. Therefore, do we need to get the 2's complement or whatever the thing? No. Then directly convert 1 0 1 0 1 0 1 0. So you can convert 1 0 1 0 1 0 1 0. That is the answer. No? So you can convert, it is 170, same as the C. It is 170. Therefore, that is why output is 170. And there is a question from Megama LH. So we should explain how the output comes in the exercise, right? So it okay to upload a PDF file. Yes, you can upload a PDF file. Okay. Then now you know that I explained most of the thing. Likewise, explain the A and C. No, explain A and C also I explained. Likewise, whatever the way I explain. So write it in your own words. That means like this kind of way you can take a photograph and upload as a PDF to the Moodle. Okay, any questions up to here? And this is the end of the lab session. If you don't have any question, I can conclude the lab. Okay, and there is a again private message. So always when you are providing, put it to the public. So for the question number 5, -2, I got the answer, but I want to rearrange them and guess the answer and check it that process. I had some difficulties figuring out the real process behind that. I think it occurs unexpected behavior with the different expression. For example, x plus equal, my answer was 46, but the answer is 47. Okay, you are asking x plus equal. Just copy. You are asking about question number 5, no? So which one you are asking? It is second question of 5th one. Second question. You are asking this one, no? Did you ask this question? So which question you are asking? Fifth one. Fifth one mean fifth one. This question, no? Okay, I'll copy this one. Paste it here, and what is the output? Output is 46. What was your question? My answer was 47, but the answer is 48. Your answer is 47. The answer is correct. It is 46. This is the rearrange. Okay, you rearrange that one using this one. Wait. rearrange. Still it is 46, no? X plus equal x plus plus x plus plus and plus x. Am I correct that this is one after you rearrange? Still it is 46. So I can explain that one. Okay, now and there is a variable called x is 10 and x plus equal plus plus x plus x plus plus and plus x. Okay, the meaning of plus equal mean x. So I can rewrite this one. Meaning of plus equal mean x equal x plus this one. That means x equal x plus this statement. That means plus plus x plus x plus 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 x. That is the expanded version of plus equal. That means for an example, x plus equal 1. Okay, meaning of this one is x equal x plus 1. If you convert the same thing, x equal x plus plus x plus x plus plus x. Okay, now you know the plus plus that what is the operation procedure? Okay, that prefix and postfix plus plus has the highest priority rather than this plus and this plus. May plus වලට may plus වලට may x plus plus වල priority ready. Okay, plus plus and minus minus, they have the highest priority. Therefore, what we can do, this one has the highest priority. Okay, plus plus x and x plus plus, they are in the same thing. They have same priority. Then which one execute first? Plus plus x or x plus plus? Because they have the highest priority and the same level. Therefore, you have to execute from left to right. Therefore, x plus, I evaluate this one. Plus plus x. Plus plus x mean, what does it mean by plus plus x? This is post,
Incrementing x and then returning the value.
yeah, incrementing the x, after that return this. First increment. Now x is 11 and return that value 11 to the here. After that plus. After that you have this one. X plus plus. X plus plus mean first put the value. That means first put the value to 11 to here. After that increment. After that this is 12. And plus x. Okay. Now you can get the value for the other x value. Okay. Plus x is now 12. 11 plus 11 plus x. X is now 12. Okay. Now what is the value? 2, 3, 4, 5, 6. 1, 2, 3, 4. So answer is 46. That is why answer is 46 here. If you want, you can run this program. Answer is 46. In my compile, I got 47 as the answer. I think there is a screenshot available. Your one, you got 47. Yeah, I think sometimes it's based on the compilers. I think if you use the online compile, I think it's maybe the different value, no? Let's copy this one. Let's make online compiler. Yeah, it's mentioned output is 47. I don't know how does it happen. Yeah, but however, the actual way of representing it should be 46. Okay, according to this explanation, it should be 46. Okay, but sometimes based on the compiler, this prefix operator may evaluate as postfix. Sorry, this postfix of one may be evaluated as prefix in some compilers, but here you got 46 as the answer. No? But don't worry that this should be the answer. According to your explanation, you are correct. But your compiler give you the wrong answer in my one also, it is 47. But don't consider that this should be the answer. Did you get that one? Any questions? Okay. Do you have any other questions? If you don't have any question, I can conclude the lab session because I think I got more than 2 hours. No questions. Okay, seems to be you don't have any question. Therefore, I conclude the lab session. Thank you for your participation.